Good morning, everyone. It's 10 o'clock and time to start. So welcome to our webinar today. The topic is asset performance management, and more specifically, we will go through the predictive analytics part of the asset performance. So let me show you the agenda. So first, we will go through kind of a general overview of the APM, and then we will take a look of this to the AVEVA Insight as a product, and then also AVEVA Predictive Analytics. And then in the end of the presentation, or in the end of the webinar, we will have a few minutes for the questions and answers. So please feel free to send questions through the Q&A box what we have in Zoom. Our main speaker today is Maria Gervits. She's working for Klinkmann in Russia, and she's been working also for AVEVA for a quite long time, and she's a specialist in this APM area. So I think, Maria, it's time for you at the moment, so you can start your sharing, and I will disappear.
Thank you, Janne. So today's topic is asset performance and what AVEVA have in their portfolio for asset performance management itself. So for monitoring equipment status. So if we are talking about asset management, first of all, we should mention that any initiatives, any projects or pilots or any systems used for in this area should be aligned with overall asset strategy and corporate objectives of any company. So if you have some initiative coming from top management, so you can try different approaches and use different tools, software tools, first of all, to better operate, better maintain your assets, and also have some savings on it. So first of all, there should be some corporate initiative on it. So it should be like business objectives. And later on, it goes down to asset strategy, and to be performed, there should be like a framework for any initiative, any projects. So when we are talking about predictive analytics, for example, for sure there should be some kind of landscape in company. There should be some information layer where production data is collected and can be used at some point. So it is not siloed servers or data. It should be used in some reports. It should be used for some KPIs, and it should be used in everyday work and operations of people at shop floor. So when we are talking about predictive analytics itself, first of all, we should mention that the main idea of AVEVA nowadays is to move most of the operation in cloud, and in cloud solution provide most of functionality of their software products. And if we are talking about predictive analytics, for sure, we should mention that it could be used in cloud solution as well. So nowadays there are many companies who would like to move their operation to cloud, their data, and to be accessible from anywhere. Especially nowadays, if we have all these lockdowns and people are not allowed to sit in offices next to each other to communicate, there should be like some software tools, systems which allow different people to understand, to see what's going on at the shop floor, how equipment is operated, how it's running, what issues there, and only call people for any actions if it needed. So cloud solution of AVEVA, it's called Insight, and it's accessible free of charge for 3 months nowadays, and you can go there and try it by yourself. So if we are talking about APM functionality, we should mention there some functions, some tools which migrated in cloud. First of all, it's like condition manager. So based on signals from automation, there could be configured some logical rules which trigger some work requests and some alarms, for example, which lead to some maintenance actions. Next is some, I will skip this slide, interesting function on historical data. It's called predictive analytics, but it's kind of function which is passively works on data and define if there is like abnormal behavior. So it is, for example, if you have some instrumentation, for example, registering temperature of water, and at some moment it is like showing some strange signals. It could be the reason if this instrumentation out of calibration or some errors or some dirt there. So that's why it generates wrong signals. So this predictive function which watch your signal could easily create alarms and rotation of operator if something is going wrong. For sure, it is not a kind of diagnostics. It does not tell you what's going wrong, but if there's some abnormal behavior of signals, you can easily do something so automatically. This kind of function makes more actionable data. So it's not just stored and archived in your servers, but it is like passively analyzed by modern algorithms. So it does not need any configuration from people. It doesn't need any extra efforts. In AVEVA Insight and Cloud Solutions, this function called Newsfeed. So it's like a little box which shows you some alarms, drawing attention, and you could just go there and see what's going on. So what about predictive analytics else? If we consider some more deep analysis of behavior of our assets, if we're talking about like diagnostics, if we're talking about analyzing what's going on, if we want to understand what's the reasons of wrong behavior or downtime, we need like more deep analysis, like more sophisticated algorithms and approaches are implemented. Just recently, AVEVA announced that their asset performance predictive analytics tool for asset monitoring, previously called PRISM, migrated to the cloud. Nowadays, it could be used like a model, extra model to Insight cloud solution, and you can open its screens from there as the same, like if it's like installed on your laptop, on your servers, and it could be easily accessible from there. So on this slide, you can see some advantages of using this technology. So first of all, it's like a proven ROI. So this kind of solutions, very easy and could be deployed in short time. It doesn't need any like huge investment in server base, configuration for data centers, etc. It's very easy to use. It's very easy to configure data collection there. And it's like from the very first minute, you can see some results. So if we're talking about predictive asset analytics software, like PRISM previously, the technology itself is built on some ideas. First of all, in this software, for modeling equipment behavior used historical data. So it is not like formulas, some physical equations, etc., quite complicated and not easy to calculate it. So using your own historical data could help to build quite adequate, real to life, real to your specific piece of equipment model, and use it for monitoring for some catches if any problems appear there. So first of all, first stage is collect historical data. If we're talking to customers who is interested in predictive analytics, first of all, we tell them if you don't have instrumentation and already some infrastructure, some framework for data management, if you don't have historian, it's not possible to use predictive analytics. It should be like step by step. First of all, you should have data. And if you have this data, you can apply some tools for analyzing it, for using it. Usually for building models, we need about 12 months history of like normal operation of particular asset. And it could be used, it's loaded to the tool and processed, and so how models are created. This approach, it's very easy, and it also doesn't need any software development skills or data science skills. It could be performed by engineers who understands how particular equipment behaves, how it operates, what kind of problems could happen there. So it's just, let's say, basic engineering background, mechanical engineering or chemical engineering. So it depends on people working on particular plant, shop floor. So next is this statistical model. It's processed in the system itself, and it creates so-called operational profiles. Operational profiles, it's all the states of your equipment possible depending on the load, on time of seasons, etc. So usually it is a set of signals and their values connected to each other. So when we are talking about building models, it takes not just one temperature and its profile. It is collected different parameters connected to each other. So if you have like increase in vibration, for sure system understands that it will lead to loop boil temperature increase as well. And if you have like a case of your compressor and you have several sensors for vibration, you can see that if it vibrates, vibration increases, it will increase in all the signals at the same time, because it's the nature of this phenomenon. So system understands it, and all the correlation automatically keep in analysis. So when predictive analytics works, it generates profiles, and later on it works in online mode, reading signals from historian, from real-time data, and compare it with these profiles and calculate the deviation. So that's how you can get alarms, like it's in this system, it's called catch. It's some kind of deviation, and you can monitor it and do some investigation. So in this screen, you can see like some trends. For sure, from first sight, when you see trends, it's not possible to understand how different signals are connected, correlate to each other. So what's the dependencies between them? And some signals could increase quite fast. Some signals are quite slow to change. And system for predictive analytics, their algorithms automatically could compare slight changes in signals and compare it all together. So usually if we're talking about monitoring of complicated, like complex assets like turbo compressors with turbines, with several stages of compressing gases, and a sophisticated loop oil system with pumps and many sensors. We are talking about thousands of signals. It's not possible, but like normal human being to analyze it from trends. There should be system which will monitor it automatically, and if any like abnormal behavior appears, create like a tag that look at this. So here is like how it works, why it's better than like standard threshold SCADA system, which can create alarms. What's the difference? So here you can see a trend. It's changing trend of temperature of bearings over time, and there is 200 degrees threshold limit for it, and we can see that there is like some correlation at some point, so it slightly changes the temperature. But at some, when predictive analytics itself works, it generates for every moment like a range for this temperature, for this signal, and system expect that actual value will fit this interval or maybe slightly deviate. And if any like significant deviation appears, system could see if it's like a trend of increase or decrease the value of this signal. And if it is like a trend, it will create alarm for you, will inform operator. So here you can see like a red line, it is actual value of temperature, and predicted values, it's blue and green at the same time. It's like interval. So at some point we can see there's like a deviation. So temperature start to increase. And at the same time, you can see that the limit established in SCADA system, for example, it's far away, but still we can see that temperature start to change. So idea of predictive analytics, why it works so well, is that it could catch slight changes, but not data spikes, and inform operator about it. And usually it takes several weeks or months before when this temperature increase reach the limit. That's advanced. You can use to plan some actions to maintain your equipment and prevent your asset from emergency stop downtime. So here is the same picture, the same situation, but if we look at two signals at the same time. So these graphs are not like drawn on purpose. They're just screenshots of user interface of predictive asset analytics tool. So here's two signals. It's bearing temperature and oil temperature at the same time. One point, it shows the values at the same particular timestamp. So if we load data to the system, we can see some like data clouds, like clouds of dots. And here we have our limits, our thresholds. And you can see that for SCADA system with thresholds, limits, all normal values, any values which are inside this square. And for predictive analytics, it's like much more narrow area. It is everything which is inside of these squares. So that's how the algorithm works. It takes actual value and check every square if it is, this value fits inside it. And if it is out of any squares, it calculates which square is nearest to actual value and calculate the deviation. That's how system estimate how much we go away from expected profile, from expected operational regime. So model building itself, as I mentioned, doesn't need any software development skills or data science skills. You don't need be expert in different algorithms. Algorithms itself are built in the tool, software tool, and it is a property of AVEVA. So it is unique combination of different algorithms which works on most equipment types. So how we create the model? First of all, what is model in the system? Model is a set of signals which represent some area or subsystem in your asset. For example, if we are talking about mechanical model of turbine, so all signals which are related to mechanical state of turbine will be collected in one model. That helps to better diagnose the problem and locate it. And also usually signals related to one area, for example, so mechanical state of equipment, it's easy to understand what's going on, like better to understand what's the reason, what's the core, and what's the cause of such behavior of asset. So here, screenshot of application, you can just start from importing data from your historian. It could be direct connection to historian, or it could be text file with comma separated value. So it could be Excel, for example, for specific format. You load data and you could create your models using existing templates. Templates, it's already predefined models with set of signals and diagnostics rules for different type of equipment, like mostly used. So pumps, for example, are used everywhere, and there is like a set of different types of pumps, and you can see what kind of signals you need for building up a model. So at the right side, you can see a list of signals in template, and you easily map your text from historian in order to create your model. It takes usually like 15 minutes to do that. So when you load data, it needs some analyzing this data and represent it in like a more visual way to understand what's going on. So here you can see again screenshots. It provides data visualization in like traditional trends, and also some two signal representation, these clouds, and you can see that how your signals looks like. So here in the screenshot, there's like two clouds of signal states of equipment, which represent maybe different types of operation, or maybe different conditions, or maybe some problems occurred there, or maybe some testing running was there. So when you click on the screen, you can easily see on trend at which moment that happens. That's how you can make decision if you want to include this data in your model or not. As I mentioned previously, models are built based on statistical data, on data from historian. So here a more closer look, we can see that our data is two bearings temperatures, so they are correlating, and we can see like two data sets representing its correlation. And person who is working with the tool could make decision which is like more desirable, what is more normal for this particular equipment. So the selection of data, it's could be performed easily again in visual way. So this red line, it is not like just a drawing, it's functionality of software, how you select some data sets and how you manipulate with them. So you can exclude them from your model because you consider that it's not relevant to normal operation, normal state of your equipment, and use or include some other data sets as well. Also, all data spikes are deleted because it is not relevant to real values, real state of equipment. And later on, we create profile, and after profile is generated and working online, so querying data from historian real time and comparing with model result like predicted values. If any deviation like found, it creates alarm in client application. Client application looks like this in this screen. So it's on left side, you can see a list of equipment pieces and different columns representing what kind of alarms it generates. So system itself, it's smart one. So it will give you some right types of alarms. It could be, for example, alarms telling that it is problem of instrumentation, or maybe it's a problem connected to some wrong data coming from historian, or maybe it could be like wrong, not updated model. For example, if there was downtime and some maintenance was performed on particular asset, for example, bearings were changed. So the temperature profiles later on will be different, the vibration will be different, the overall behavior of asset will be different, and system itself, it will create alert that new data model should be updated. And it is how model should be trained, how system is trained. So you just add extra information for it all the time. And that's the way how you work with your models. Models are specific to particular asset, to particular equipment piece. If you have like 100 pumps, all the same model, operating at the same shop floor, but they are different because they could be like different angles, how it's installed, maybe different run hours, different maintenance activities, or downtimes at different time moments. So it is, everything is taken into account. It is unique asset, and for it, it will be created a unique model. And this model should be kept up to date, considering all the operation, all the activities performed on this asset. And that's how you can easily tune the model and keep it up to date all the time. So there is no need to get involved any software developer or data scientist all the time. It can be done like on regular basis from client application. So here is how it works for alarms management. So it's not just red buttons there appearing, there is some logic behind. It is very similar to alarms in modern HMI systems. So it is not just everything is in red. There's some stages how you consider, how you work on your alarms, what actions are performed. And the main idea of predictive analytics just not give your alarms that something is going wrong, but be a starting point or of a workflow, how you investigate what's wrong with your equipment and what actions are performed in order to fix the problem. So here is also very important function of this software. It's like a case library. So if you have any problem with equipment, you can describe how it looks like, create like a diagnostic rule. So it's a logic combination of signals and their behavior, for example, increasing, decreasing, or staying at the same level, and also some actions could be written here, and you can store it in system. And next time, for example, you have similar problem and alarm pop up, and it is apply diagnostic rule, and it says that it's like a bearing problem like that, and also give you some insights how to deal with this problem. So idea is that if any downtime happened, so there should be investigation, how it's happened, why that happens, what actions were performed to fix it, and what actions should be performed in order not make this happen again. That's how this knowledge could be kept in the system. So besides that, there is very interesting function called data playback. That function gives opportunity to load historical data and run the model and algorithm on historical data. For example, if you have already history and you want to play and see different what-if analysis. So you have already downtime and something is broken, and you can see using this system how in advance the system could give you alarm about this problem. That's you can play different scenarios how you could eliminate issues in your shop floor. That's like more analytical tool. And also this tool could be used for some offline pilots when customer is interested in if this software works for them. They give some historical data for a couple years, and they know that they have some issues there, and system could show it. And we can prove that this technology is working on real examples. So here in this screenshot, you can see some diagnostics, so how it looks like. When you click to alarm, you go deep down and you can see which signals deviate the most and which diagnostics rule apply to them. And it gives you like a trend and shows at which moment it appears and how it's developed. So here's like more analyzing representation of information. Also, you can see here all the trends of all signals connected to this alarm. So it's like more deep dive to this issue. So nowadays, there are many predictive analytics tools for monitoring assets, and most companies who is creating some equipment, they try to use new technologies. So what is the advantage of AVEVA predictive analytics? First of all, AVEVA is not connected to any equipment producer. So we are absolutely independent. We are using any data sources. So it's not only Wonderware traditionally, but we have like native integration with them. But we can see, we can use any data sources at shop floor. So which supports industrial standards, and it could be any equipment types monitored by the system. It could be like dynamic equipment, like turbines, compressors, like drives, fans, etc. It could be also some static equipments like boilers, heat exchangers, ovens, kilns. It could be like some electrical equipment like transformers as well. So there could be like a quite big range of equipment and asset behavior which could be monitored by this system. So the value of predictive analytics itself. So first, it gives really like some information in advance. So you have something which is like not happened already, but starts to develop, because like all damages in equipment, mechanical destruction, not happening at the moment. It's like takes some time, and if system is quite sensitive, it could create alarm at early stages, and some actions could be done to prevent it from downtime, from really destroying the asset. Second, it's like point is second set of eyes. So usually we try to automate everything, and even the knowledge and experience of people. So this kind of system is quite sensitive, and if some experienced people know what's going on with equipment, they could describe and define their knowledge in like diagnostic rules in to pass their knowledge to the system. So next time the same issue could be faster recognized, so by system. So that's how we can use knowledge and like implement it in IT system. third advantage is like right size. We can see how much maintenance efforts should be performed to particular asset. So some assets are like not enough maintained, and some are over maintained. If everything is going okay and system doesn't give you alarms, so maybe there is no need to do some extra maintenance on it. But if there is some alarms, you maybe pay attention to some pain points. So here's like a pie charts defining which kind of issues could be defined by predictive analytics. So like the biggest, it's everything about reliability. Second big is about vibration. So we should mention that this kind of system, predictive analytics, it's not a substitute of vibro diagnostics tool. For sure, it should be in place, but usually vibro diagnostics, it needs some very like highly skilled specialists who understand what's really going on. But as I said, besides this vibration issues, there are many issues could happen with your asset, like miscalibration of instruments, like wrong operation, or maybe need some tuning. So you're not loading your specialist with some like wrong information. You just call for diagnostics only when you really need these people and you need this service. Now, here in this slide, you can see a real example how it works, the system, with some screenshots and pictures of real issue. It company EDF, Energy de France, they have a steam turbine, and it was started up after a downtime. They performed some regular maintenance, and the problem was they have some bolts which were loose, not tightened. And when they started up, it started to vibrate, and blades of turbine start to destroy. You can see it in pictures. And on right side, you can see how it looks in predictive diagnostics tools. You can see that it was like normally operating, and actual values are in red line is deviating between like predicted values, blue ones. Then it was downtime, and then it was started up. And after startup, you can see that actual values, red line, it's like much more higher level than predicted ones. That shows operator that it's really going something wrong, and they made decision to stop asset and have a look what's going on wrong inside. So estimated cost of the issue from this early catch is about $4 million for them. So for EDF company, they're very interested in how they develop their organization of their monitoring center using predictive analytics. So they divided three levels of monitoring center. First level is their sites, mostly it's power plants. They have real operations there, and they have some maintenance and operation people working on shop floor, performing some actions. At the level 2, they have monitoring centers with 2 engineers who are using predictive analytics software, like I explained to you. One guy is working with alarms, so he's created cases, and he's monitoring, and he is creating some request maybe to AM system, or changing if it's the state of alarm if problem is fixed, etc. And second person is working on models, so keeping them up to date. As I said, models, it's not something like fixed and not changing anytime. It's living and changing with equipment, like following its life cycle. And level 3, it's experts. It could be like experts in diagnostics, vibro diagnostics, for example, or people who know and are experienced in particular type of equipment. So here is how it works. So usually if a company decided to implement predictive analytics, they should implement as well some business process for it. So who will work with this software, how they will interact with other departments, how the issues will be resolved, and how it will work all together. So it's very important topic, and it should be defined from the very beginning with customer if they have idea to try predictive analytics. So predictive analytics could not stay isolated. It is software that gives some information, and this information should be taken in action. So here you can see some pictures of such monitoring centers and logos of company who is using this kind of solution. So from European, it's Enel company. It's with their monitoring center not far from Rome. It's some chemicals companies like BASF, Calpine, petrochemical Total. So all these companies are used predictive analytics in their monitoring centers. So also some slides about success stories. Duke Energy, it's power generation company in the United States. So they were maybe one of earliest adopters of these technologies. For them, downtime of their assets is quite expensive because they have contracts, and every minute costs millions for them. And they try to monitor their assets in order to provide most maintenance in the scheduled downtime gap and decrease number of unscheduled downtimes. So Total, French company everybody knows, they have two divisions. They have upstream and downstream. So for their downstream assets, they use Prism. And they also adapts of cloud solution, and they use it in the cloud. So Air Liquide, it's a global company producing industrial gases, so gas separations, have many sites. They are quite small, so usually they have most of the equipment that's compressors. And they have several divisions for Europe. For example, in Brussels, they have a monitoring center where several people sit, and they monitor all their sites in Europe and Russia, and CIS, like Kazakhstan, I guess. So usually they have like small site nearby big plant. For example, in Russia, it's Severstal site. It's steel making facility on north, and they have a plant producing gases for them. So it's like a joint venture with Severstal. So we have also additional presentation from Air Liquide. We ran together a webinar previously, so we can share after on request with you their slides if you are interested. It's open to use. So that's all for me. Jana?
Thank you, Maria. That was very, very nice. If there's some questions, please share your questions in the Q&A. There's one at the moment. Can you, Maria, see it directly, or should I read it to you?
Yeah.
So could there be such situation that AVEVA says for the operation of our algorithms we need additional data, which means new sensors, etc.? Or do you adapt to what is available?
No, usually we are not talking about additional sensors for sure. Like if you have no sensors at all, it's not possible to apply any predictive analytics, as I said. If you have sensors, but you have no historians, it's also very hard, because if we install a historian and collect data from these sensors, we need some time before we collect some history, because as I said, for good models, we need at least 12 months. So usually it covers 1 year operation. So if we are talking about additional data, that means that we need some logbooks information. For example, we should understand what was going on with this equipment. For example, what kind of maintenance was performed on this equipment. We can see from signals from historical data that there was a downtime, but in order to understand, to interpret it in right way, we should understand what's going on. Usually in companies, they have like logbooks, or they have some maintenance database. For example, Air Liquide, they collect all this information by now over 15 years. So any action performed on equipment, it's recorded in some database, and they could analyze it. That's what is mentioned about it.
Okay, thank you, Maria. Any more questions? The box is empty at the moment. Any comments or something? Seems to be so that everything was clear. So
okay.
Nice presentation. So if we don't have any more questions, I would like to thank everyone for joining today, and then I believe there will be some feedback from our marketing later on, and we will share the material and links to this was recorded, so it can be also watched as on demand. So thank you very much for joining, and I think we can close the webinar today. Thank you.
Thank you. Bye-bye.